Now let's look at this problem. They have graphed the data for us. This is not a normal distribution. Since it's not normal, what's the checkbox? The checkbox is that the sample size has to be larger than 30, and here we have 59 player salaries. Now they gave us a value for sigma, so even though this is not normal, we know that the mean values for all the sample sizes would be normal. So given the population standard deviation, we can go ahead and find a z value for this one. So let's come over here to StatCrunch. To find the z value, let's go to Stat, Calculator, Normal for a z value, because that is the standardized value. You can go ahead and leave the mean at 0 and the standard deviation at 1. The z value for any percentage confidence level never changes. So you don't have to change the mean or the standard deviation anything. I'm going to go with a greater than or equal to. Since the confidence level is 99%, then alpha is 1%. Alpha over 2 would be 1/2 of 1%, which would be 0.005. My z alpha over 2 is going to be 2.5, 2 decimals, 2.58. And we use the z because it gave the population standard deviation sigma. Keep that in mind. Even though it was not a normal distribution, as long as the sample size is over 30, you go by which standard deviation you're working with. If the sample size is under 30, that's where you have to work with the t-value, regardless. And then that's where it's required that the distribution is normal. Let's change this one up. Here's summary stats for randomly selected weights of newborn girls. N is 239. X bar is 33.9. S sampled 7.5. Construct a confidence interval estimate of the mean. Use 95% confidence level. And then it says another question, are these results very different from the confidence level of 32.2 up to 35.2 with only 20 samples? And then they give us the data about how they went about getting that confidence interval. So we've got a much, much, much larger N value. X bar is not too far off. The standard deviation in ours is actually much larger. So let's see what kind of confidence interval we get with these numbers. Now, are we going to use Z or T? It doesn't say anything about being normally distributed. We have S, not sigma, so we have to use T. So let's go with stat. Let's see, we're looking for the confidence interval. And the confidence intervals are going to be found in Z-stats, T-stats, or the proportion stats. You might want to write that down. To find a confidence interval, go with Z-stats, T-stats, or proportion stats, whichever is appropriate. This is going to be a T, one sample. The other sample's already been run, don't worry about that. With summary, our sample mean, 33.9, sample standard deviation, 7.5, sample size, 239. We want to go with a confidence interval, 95%, compute. Our confidence interval for this sample is between this lower limit and this upper limit. So 1 decimal place, we're going 32.9 is the lower, and 34.85 will round up to a 9. Now compare our confidence interval that we got with this sample to the confidence interval they got with this other sample. This one was 32.2 to 35.2. Ours is a little tighter. It's actually completely within this confidence interval. So they're not that different. If they didn't overlap, that would be different. Anytime they don't overlap, that is different. So are they very different? No. Because each confidence interval contains the mean of the other confidence interval, or just because they're similar. We really didn't even worry about means too much. Let's just call it because they're similar and see how they like that.